All right, let's pull back the curtain on artificial intelligence. But we're not going to talk about algorithms or code today. No, we are going on a physical journey into the massive, hidden world that actually powers every single AI prompt you make. You know how it is. You type in a question, you ask for an image, and boom, like magic, an answer just appears. But what's really going on in those few seconds? Where does your prompt actually go? Well, the answer takes us to some very real and pretty surprising places. So that simple request you made, it instantly travels through a physical network of fiber optic cables to a very real, very large building. We love to call it the cloud, but really it's more like a specialized factory built to process data on an absolutely incredible scale. And that brings us right to the heart of the operation, the AI data center. You can think of these places as the engine rooms of our digital age. But the engines that are running AI, well, they're at completely different beasts than anything we've ever seen before. I mean, just look at the sheer difference in power here. A traditional server, the kind that runs a normal website, it pulls about 150 watts. But an AI server packed with GPUs to handle all those complex calculations can draw up to 1,200 watts. That is a massive 8-fold power jump just to process one of your prompts. So, when you're drawing that much power, you simply cannot afford to go dark. Not for a second. These data centers demand a constant, totally uninterrupted flow of electricity, which brings up a really important question: reliability. So how do you even measure that kind of reliability? Well, the industry has a system for it, and it's called data center tiers. It's basically a standardized rating for how resilient a facility is, ranging from the most basic, Tier 1, to the incredibly fault-tolerant Tier 4. And here's what those tiers mean in the real world. A basic Tier I facility, it could be offline for over a full day each year. But a top-of-the-line Tier 4 data center, we are talking less than 27 minutes of downtime for the entire year. That incredible level of reliability is achieved through a concept called redundancy. A key idea here is something called N+1 redundancy. So think of N as the number of power or cooling units you absolutely need to run the place. The +1 is a complete, independent backup of everything, just sitting there, ready to take over instantly if anything fails. That's the secret sauce to getting that amazing uptime. Okay, now that we kind of get the hardware, let's zoom out and look at the staggering scale of resources this whole global network of AI engines is actually consuming. And I gotta tell you, the numbers are almost hard to believe. Just look at this projection. By 2025, data centers are on track to use 536 terawatt hours of electricity. But as AI explodes, that number is projected to nearly double, to over 1,000 terawatt hours by 2030. That is just a staggering surge in demand. To put that into a bit of perspective, here in the United States, some projections suggest that by 2030, data centers alone could be consuming up to 9% of all the electricity generated in the entire country. 9%! And this is the core reason for that huge surge. This quote from Deloitte makes it crystal clear. A single generative AI request can use anywhere from 10 to 100 times more power than a simple Google search. So every single prompt has a very real and very significant energy cost. And it is not just about electricity. All that hardware generates a ton of heat, and cooling it all down requires water, a lot of water. By 2027, the annual freshwater demand of AI data centers could hit a staggering 1.7 trillion gallons. Okay, so if these facilities need so much power and so much water, where in the world do you build them? The answer isn't as simple as just plopping them down next to big cities. No, it's a very strategic decision based on a unique set of geographic and infrastructure factors. It really comes down to 4 critical things. First, you absolutely need cheap and reliable power. Second, you need access to water for cooling. Third, you've got to be plugged into the physical backbone of the internet, those dense fiber optic and subsea cables. And finally, you want local governments that are willing to offer you tax breaks and friendly zoning laws. This combination of factors creates these massive superhubs. And the most famous one of all is Data Center Alley in Loudoun County, Virginia. And it's no joke to call it the capital of the internet. An estimated 70% of all global internet traffic flows through this one county every single day. And this table really shows the sheer scale of that concentration. Loudoun County already has nearly 6,000 megawatts of data center capacity, with another 6,300 planned. That is more than any other county by a long shot. You can also see other major hubs popping up in places like Maricopa County, Arizona, and Prince William County, which is also in Virginia. So this explosive growth creates an enormous challenge. How do we power this future sustainably? Well, the industry is acutely aware of this problem, and a multi-pronged strategy is already emerging to tackle it head-on. Deloitte identifies 5 key strategies here. It all starts with the hardware itself, making the chips more efficient. Then it's about optimizing the software and shifting some of the processing to edge devices, like your phone or your computer. It also means right-sizing the AI models so you're not using a giant model for a simple task. And finally, it all comes down to deep collaboration between the tech companies, the utilities, and the regulators. And there's some really fascinating technological innovations on the horizon, too. We're talking about things like advanced liquid cooling, which could slash the power used for cooling by 90%. Companies are exploring building their own power plants on site, they're investing heavily in renewables, and they're even finding creative ways to recycle waste heat, like using it to warm local homes and community swimming pools. And this leads to a really powerful and maybe unexpected benefit. The tech industry's massive financial power is now actually accelerating the green energy transition. By signing these huge long-term contracts for renewable power, they are directly bankrolling new wind and solar farms that end up benefiting everybody. Which leaves us with the central question of this whole AI revolution. We are building these tools of unprecedented power, but they come with an unprecedented appetite for resources. The great challenge of our time is going to be whether our innovation can outpace our consumption.